If the time permits, we'll see some more case studies. I've seen in the chat box. Okay. Okay. Welcome all after post lunch session. Okay. And I will keep you to, through this session. Uh, now, sorry. After understanding the importance of phase, okay, and spectrum analysis, then various different scenarios, some case studies भी हम लोगों ने देखा, okay, and after that you must have realized कि वाइब्रेशन स्पेक्ट्रम एनालिसिस इज वेरी वेरी इंपॉर्टेंट. जब भी जरूरत पड़ती है, हम दुविधा में होते हैं, तो फेज एनालिसिस हमारा लिए एक हेल्पिंग हैंड रहता है. और हम लोग को जो डाउट्स है, दैट डाउट ही फेज क्लियर्स एंड एग्जैक्ट सॉल्यूशन इट प्रोवाइड्स अस. ओके, सो व्हाट इज द फेज? फेज इज द डायरेक्शन ऑफ वाइब्रेशन. और स्पेक्ट्रम एनालिसिस, any problem in a machine you can detect from it, and the different kind of problems has a different spectrums also, and based on that analysis, that study, you can find out what is happening with your machine. एम्पलीट्यूड लोअर लेवल पे है, नो प्रॉब्लम. एम्पलीट्यूड डेविएट होता है, गो फॉर अ स्पेक्ट्रम. स्पेक्ट्रम में आपको एक रास्ता मिलेगा, एंड स्पेक्ट्रम में यदि कोई दुविधा है, गो फॉर अ फेज एनालिसिस, फेज डेटा कलेक्शन, देन एनालिसिस एंड कंफर्म द source of the fault. Then moving ahead, सबसे बड़ा फ्रेंड, फिलोसोफर, गाइड, मददगार, शुभचिंतक, जो भी हम बोलते हैं, वो उसके बारे में हम सोचने वाले, उसके बारे में हम बात करने वाले, डिस्कस करने वाले. हु इज दैट फ्रेंड? हु इज दैट helping hand? That is a oil analysis for the वाइब्रेशन एनालिसिस. कि जब भी जरूरत है मुझे, मैं दुविधा में हूं, उस टाइम पे और एक मदद वाला फ्रेंड जो है, दैट इज अ ऑयल कंडीशन मॉनिटरिंग.
Sir, sorry to interrupt in between.
Yeah.
Sir, actually, since our participants are from across the country
Yeah.
and some are from South India also, so there is a request from the different participants if you can explain the case studies
Please.
in
Okay,
English
okay.
as well.
No problem.
And sorry, sir, for the interruption.
Yeah, thank you for informing me. So the biggest friend in the condition monitoring field, or in for vibration, I will call it as a oil condition monitoring. So what is the oil condition monitoring? Whenever there is a problem or there is a doubt, you must go for it. Okay. Suppose there is a sound from the gearbox, the vibration level is deviated, the acceleration value is deviated, but you cannot pinpoint whether the bearing is damaged or gearbox gears are damaged, or some else is the problem is there. At that time, you take a help of oil analysis, and it will clearly indicate you what is the problem in your machine. It is just like a human blood test. Ki, if in front of the doctor two patients are there, same, one person X having a 101 fever and other person having 102 fever, he cannot directly say 101 you have malaria, 102 you have a typhoid. No, he cannot say directly. He will go for a blood test, and whatever the results are from the blood test, he will confirm, oh, 101 having a typhoid and 102 having a malaria, or vice versa, or whatever. Means to pinpoint, whenever the pinpoint the defect, the oil analysis plays a vital role. So today we are going to see the two different parts of the oil analysis. Okay, then the procedure of that, and then the important case studies. How the oil analysis helps in condition monitoring. Oil analysis helps whether I should go for oil change, whether I should filter or centrifuge the oil, whether I should replace the internal parts of the machine, whether I should go for chemical testing or anything else, whether I should top up the oil and maintain the properties similarly. So all the decisions, it is not like that the oil deviations noticed, replace the oil is a simple solution, but it has to be last solution, because environmentally we should not damage the area where we are throwing the oil. Okay, so before starting this session, I just wanted to show you one video. Okay, so stay with me. The sound is not important, but whatever the key punches you will see, that are most important. So the question is, why should I go for an oil analysis? So this is a solution. We are wasting a lot of oils just by replacing, sometimes too early, sometimes too late. Here was a punchline: every oil drop tells a story. Any material defect, particles, it can detect easily. Contaminated oil or grease causes a 20% loss in efficiency. See, 70% engine failures are oil or coolant related. While watching this video, only two cars crashed due to contaminated brake oil fluid. So severity is very dangerous. And just because we don't test the oil. And everything we can avoid just by testing 100 ml or 200 ml bottle oil. Coming back to the PPT, so you must have just understood that, sorry, you must have understood that with this video, what they are going to tell us. With Without monitoring the oil, lot of losses are there, accidents are, safety hazards are there, industry loss is there, efficiency loss is there, machinery parts damage is there. But with oil analysis, just using a 100 ml or 200 ml bottle sampling, and cost is very less. Okay, by monitoring you can overcome with all this. So how to test, what to test, all the things are here. So OCM strategy, that is the oil condition monitoring strategy. What is the strategy? Routine oil condition monitoring identifies small problems within the machinery components before they become a catastrophic failures, and that can incur costly repairs or production to halt. Means it is an early detection system. If you test the oil regular basis for your critical machines, that may be a turbine oil, fan oil, hydraulic coupling oils, and any other gearboxes oil. So you test it on regular basis, so any problem before reflecting in any condition monitoring parameter, here it can reflect, and that reflection or that deviation we can identify at a very early stage, and we can take the appropriate solution, whether we have to centrifuge, we have to replace the machinery part or anything else. Okay, so that you cannot have a production halt. Okay, you can take a proper planned shutdown, and with the planned shutdown you can club this work also, and you can keep your machines safe, human safety, and all the things you can achieve. Now, what is the tribology or oil condition monitoring? These are the three important parts. What is the tribology? It complements vibration analysis, providing independent and advanced indications of mechanical wear. Any mechanical wear, it can detect if there is a mechanical wear. Just like a vibration spectrum, it has a different kind of patterns. This is a bearing failure, a bearing particle pattern. This is a gear or any say, fatigue wear, or you can say contamination, water, dust, sand, or any other. So just like different spectrums are available for the different issues, similarly here also the different microscopic images are available for the different kind of mechanical wears. It supplements the vibration analysis, monitoring the three causes, that is the oil chemistry, contamination, and component wear. Means it monitors the oil chemistry, all the chemical parameters, then contamination from outside, that is the water, sand, dust, or any other contamination, process fluid mix up, and component wear means the bearing wear, the gear wear, or any hydraulic coupling part wear, seal wear, or any other mechanical part that is inside the lube oil, that wear it can detect, and it will tell you what kind of problem is there. Then the lube related root causes. Why this oil is getting deteriorated due to wrong oil, mix up with some other oil, low degrade हो चुका है, process contamination means water is getting mixed up or steam is getting inserted or anything else. So dilution, water contamination, dust contamination, CHP area, AHP area means coal or ash particles mix up. So such kind of all the things it can detect, and you can get a perfect solution. Now, basics of lube oil analysis. So we will see the basics of lube oil analysis. Very first, what is the need of lubrication? Everybody knows that reduce the friction and wear. That is a basic thing. Prevent rust and corrosion. oil film prevents that. Okay, to remove the heat, sealing against the dirt, and the power transmission. So these are the basic or very primary level lubrication needs of the lubrication, and all in somewhat format it is used in every kind of industry. Okay, automobile, power, cement, or in any kind of industry, same applications are used for the lubrication. That is used, and that's why the lubrication is required. So what are the different kind of lubricant films? There are four types of lubricating films. That is the boundary lubrication, mixed film, hydrodynamic, and electrohydrodynamic lubrication. Okay, so I will not go in detail. When this kind of lubrication is used, the boundary lubrication is generally used when the friction is on a higher side. If the your process or the machine is having a high kind of friction, then this kind of boundary lubrication is suggested or designed. Mixed fluid, when the friction level is moderate to high, then this type of mixed fluid lubrication is designed. Then the hydrodynamic lubrication, when the friction level is very low. Okay, so fully pressurized fluid frame is used, and such kind of system is used for the low friction kind. And electro hydrodynamic lubrication for the high speeds and loads associated systems. Okay, so these are the basics of different kind of lubrication systems used in different scenarios. Okay, friction high, moderate to high, low, and the low high load and speeds. Now here comes the role of the condition monitoring. So condition monitoring through oil analysis, I just said, it is just like a condition monitoring is just like a doctor's job, and oil condition monitoring is just like our blood test of a human body. So doctor collects just a syringe, one syringe or two syringe of your blood, and you find out what is the problem, what are the issues, or whether you are healthy or not. Means what parameters you have to check. He performs accordingly the test. Okay, so we also have to confirm all the tests, and we have to find out whether my oil is in good condition or not first. Secondly, my oil is in good condition, but my internal parts where the oil is flowing through, or the oil is submerged, the machine parts are submerged in that oil, whether that machine parts are okay or not. So these two different things we have to find out. So objectives of used oil analysis, monitoring and condition of the oil, monitoring and the condition of machine through examining debris in the oil, and monitoring and correcting the contamination level in the equipment. Okay, so these two types of monitoring we have to perform, and to find out whether there is a problem or deviations are there or not. Now first is monitoring the condition of oil. Okay, how my oil is there, what is the condition of my oil. Okay, so the chemical parameters are there. That is a viscosity, water by Carl Fisher, tan, TBN titration, flash point, fire point, foaming characteristics, and emulsion characteristics. So these uh, chemical testing, we call it as a chemical testing because our chemical department is doing this. So this chemical testing, chemical property testing is done to check how is my oil condition. Okay, not from this I will not know how my machine part condition is. Okay, that is some kind of different tests are there. So first we will check how is my oil condition. Now viscosity is a very important, basic, and primary testing parameter. Changes in a viscosity indicates improper servicing, dilution, contamination. Okay, so if there is a viscosity should be a specified limit, just like your sugar in the blood. Okay, it should not be I'm not doctor. It should not be above 140 and below 70 and all these things. Similar kind of things is here also. So low viscosity also damages, and high viscosity also damages to the machine parts. Okay, so low viscosity decreases the wearing surfaces, high viscosity indicates a lubricant oxidation and all these things. So the viscosity should be within specified limit. Water contamination, the biggest enemy of the oil is water. Okay, so presence of water in a non-water based fluid indicates contamination, and water is the most harmful contaminant that leads the lubricant breakdown and component parts rusting. Okay, so water ingress should be avoided. Tan, TBN titration. So tan, that is the acid number, and TBN is a total base number. The degree tan, it determines the degree of degradation by oxidation measure, and measure of TBN is a measure of lubricant ability to neutralize the acid base system. Both are the important parameters, and that should be within a specified limit. Then the flash point, minimum temperature at which the lube oil catches the fire, that should be that should not change. Okay, that should be within that specified range only. Then the pour point, lowest temperature at which the lubricant can flow and perform its function, that is also should not change. So that as per the design or as per the requirement, that oil should perform properly. If any parameter is deviated, then your machine cannot perform properly, or it may damage, or it may create a problems in your system. Then the foaming. Foaming is a very dangerous system. Dangerous characteristics. So understand the foaming, and foaming is due to the dirt ingress. So foaming, wherever is the foaming, there is no oil, no lubrication. It's just air bubbles. Okay, so foaming has to be avoided. Otherwise, what will happen? There will be a metal to metal contact of your machine parts, and it will damage immediately. And emulsion characteristics. Emulsion. Demulsivity testing is to know the exact time in minutes required to separate the oil and water in emulsified condition. Okay. Typically, the more time taken for the oil and water indicates a poor demulsibility. Less time for separation indicates better demulsibility. So this test has to be done, and the time has to be calculated so that you will know that how the my chemical property of emulsion is there for my machine, my oil. So once you do this all the chemical testing, you will confirm if my all the parameters are within limit. No need to go for any oil replacement or any oil change. Okay, because my all oil chemical parameters are within limit. If any parameter has any deviation, then appropriate decision has to be taken. Now, just I said earlier, he oil testing in two parts. That is a chemical analysis to know how my oil condition is, and the second one, the oil where in the gearbox, how the condition of that gearbox or the machinery parts or the bearings or the seals or the gears, hydraulic coupling is. So for that, the most advanced technique, that is a wear debris analysis or the ferrography analysis, is done. So what is wear debris or ferrography analysis? We'll go see. So first of all, why the machine fails? Why the machine fails? The machine fails primary, will go from top to bottom. 15% machine fails due to the obsoletum. Obsolete, this machine has been obsolete, no spares are available from no spares is available in the market, or no support is available from the your OEM. So the machine is obsolete, and no parts are there. We use them till the end of that wear that machines, and one day they fail. Accident 15%. Some kind of process accident or some kind of any other kind of accident happened mechanically or electrically or operationally. So 15% of machines fail in that. But the most 70% of the equipment fails is surface degradation. And in that 70%, 50% is a wear and 20% is a corrosion. And corrosion, 20% is caused by just water ingress, degraded oil, process contamination. Just I said, the biggest enemy of सबसे बड़ा दुश्मन the biggest enemy of the oil is water, and because of that water ingress or steam ingress, it is causing corrosion, and 20% of the major part is surface degradation is happening and your machine is getting failed. Now come to the 50% area. For the 50%, the abrasive wear, adhesive and fatigue wear means damage resulting from abrasive particles, damage resulting from metal surfaces, and damage resulting from micro cracks causing a cyclic loading. Okay, that is caused by dirt ingress, secondary wear, low viscosity of oil, misalignment, imbalance, irrespective. So our vibration should be within limit. Alignment, if it gets disturbed, correct at right time only. Balance it at a correct level only. Then chemical parameters should be within limit. Any deviation, it will cause adhesive wear. And abrasive wear particles means secondary damages, process contamination or rusting की वजह से जो होगा, that rusting particle will mix up in a good oil or process in the system, and that will slowly damage and abrasive wear will take. And these all three will create a 50% of the problems. 50% of the share it takes of the that 70%. So bottom line is we should avoid the water ingress. We should avoid the secondary damages, secondary wear particle generation. We should keep in control all the chemical parameters such as viscosity, high temperature, excess load, all these things. And importantly, vibration control. That is a misalignment. If it happens, then you should correct it on timely. Unbalance it happens, correct it timely. Bearing wear, you should correct or you should replace at a correct time. Now, similar thing is written over here only. Now, who founded or who started testing of this such kind of oil? That is the ferrography history. So in 1971, US military aircraft, submarine engines, oils, they started. US military has started this. And slowly the technology passed on to the industry also. And they also started doing the same thing. So basics of ferrography analysis. Wear difference analysis and ferrography analysis both are the same words. Okay. It is a two parts are there. So it is a quantitative measurement of wear particle concentration and percentage of large particles. So whatever whenever the oil is means ferrography is started, first of all the sorry whatever the number of particles are there, they are calculated first. Okay, and who is the biggest person in that has identified. So that help us who is the biggest, that is the starting of the problem. Okay, and that biggest particle is analytically viewed under the microscope. That is the microscope evaluation of wear particles and contaminants to address the source and cause of wear. Okay, and this is done under the with the help of ferrogram maker. Okay, I will show you exact procedure here also. Now, what is ferrography then? Step by step, we'll go. Particles contained in oil carry a detailed information about the condition of machine. just like our blood. Our blood knows everything. Our blood has every contamination, good, bad, or anything else, virus, non-virus, whatever. So particles contained in oil carry detailed information. Everything it has, you have to just test it. Then particle characteristics are specific to the operating wear modes. Just like a vibration patterns, 1x, 2x, 3x, there must be a misalignment. 1x only unbalance is there. Higher frequencies, there is a bearing wear particles. Gear missed frequency, gear related problems, and all these things. Similarly, the particle characteristics are specific to operating wear modes. There is a gradual buildup of small particles in normal system. Okay, if there is no problem in your machine, still you will find some particles which are normal, just like a vibration spectrum. कि आपको 1x 2x that you will get it, no problem. Okay, so 1x 2x with a low vibration levels, it is absolutely okay. Okay, now there is a gradual buildup of small particles in a normal system. We don't bother with that, but whenever the abnormal wear begins, there is no sharp instantaneous increase in concentration of small particles present in the system. But what happens? There is a dramatic increase in a concentration of large particles, and we are interested to see them. Who is generating the big particles? From where they are coming from? From bearing, from gear, from seals, from shaft, or anything else? And therefore, detection, measurement, and analysis of these large wear particles can provide early accurate information about the condition of that machine. So it is very important you find out the wear particle concentration and the biggest particle in that, analyze it under the microscope, and find out from which location it has been generated inside the machinery without stopping the plant. Now, wear depths analysis, just I said, complements the vibration analysis, and it is based on systematic collection of oil samples from the lubricated system. The method identifies, isolates, and classifies the wear particles from the machine parts. Magnetic field is used to sort the wear particles in the flowing oil. I will show you the video also. This analysis is a microscopic evaluation of wear particles, identified the type of severity and the generation mode. Okay, it also helps to identifying the root cause, whether it is a bearing particle or whether it is a gear particle. Now, in this way, we have to see this. I will show you. Now, wear debris analysis process, a simple whatever we have discussed in that last two presentation slides, I have tabulated here. You collect the sample first from proper location. Test it. What is the wear particle concentration? What is the large particle size? And what it is coming from? What is the significance of it? Report it. Then the analysis is done and action is taken if required. Okay. Now, the very first step, we'll see each and every step now. The very first step, an analytical report is, no matter how brilliantly written, is worse than the meaningless if the sample taken are not representative of the system being monitored. Matlab, if you take a sample from the wrong location without discussion with the sample collection person, he will collect from anywhere. And what will happen? A wrong report will be done. Wrong reporting will be done. Analysis will be wrong. Okay. You must have seen the doctor or nurse whenever you go for a blood test. From where they collect the data? From means your blood. They always collect from here. They never say Habibi khun hai, from here also you can take, from here also you can take, or from leg or any other part of the body. Everywhere is the blood. but you cannot take from anywhere of your body. The specified locations are there. From there only you have to take the oil sample, means blood sample. Okay, so what I'm going to say, trying to say that the blood sample is taken at from the specified location from our body for the good analysis. Similarly, oil samples also collected from the specified locations only. Do not collect the samples from anywhere. Oil ही तो है, oil तो चाहिए ना, और क्या है? Such kind of attitude should not be shown. Now, what are the some important points to be taken in consideration? Sample tap in a written line of the last lubricated component. Sample wall at a two-third distance from the top in the case of reservoir tanks. In circulating portion of the reservoir at entry end or near or mid height of the reservoir. I will show you the pictures. It will clarify you. Sampling from the sum. Okay. See here. If you are taking a big sum, you should not take from the bottom, otherwise sludge will be there. Drain से भी नहीं लेना है. It should be around from half or two-third from the top. Okay. Top side से भी नहीं लेना है. You should take from here only. I have one snap. I will show you. Just I'm going back. Okay. This is our turbine tank. Okay. So I'm not taking the bottom of the tank. I'm not taking the top of the tank. I'm taking the two-third from the top. Okay. Sampling tanks when there is no provision from the written lines. Okay. So whenever there is no sampling point is there, then you should take the whenever the written line comes here and the oil is released here. Okay. Written line oil. So you should take the sample from here. You should not take from here or anything else. Some more important tips. Do not sample more than 15 minutes after shutdown. Okay. Do not sample downstream of the filter. Do not sample at dead areas or do not sample from top or bottom of the reservoir. See, the honesty while collecting the oil has to be maintained. Otherwise, what will happen now? The system does not know from where the oil is coming from. The analyst who is sitting in the lab does not know the sample is coming from. It's our duty, it's our responsibility to collect the correct sample for the best analysis. Okay, because it is assumed that you have taken care of these things. Simple but important things. Okay, because the whole analysis is based on the proper sampling only. That's why I'm giving more thrust here. If the sample is not proper, आप if you are done, अरे ऑयल ही तो देना है, दे दो कैसे भी करके, this kind of attitude if you tell keep na, what will happen? You will never find, you will miss the problem and the failure will be there. Okay. Then once you collected the sample reaches to the your lab. This is a particle count machine. Particle count machine, contamination analysis by the particle count test. This is a laser system machine. So it counts everything, metallic, non-metallic, fiber, dirt, whatever, bacteria and any other kind of debris, whatever is present in the oil. And with 3 different runs, it gives a direct report with a NAS level. Okay. So this automated instantaneous detail printing report is there. So it will give different sizes of the particles, whatever what the machine has counted, and the biggest size particles also, and all the things. So it gives instantaneous report. Okay. Once the particle count is done, then it has a standard wear particle concentration. What kind of oil is this, and what is the application is this, and whatever the particle count is there, it should be within limit. If it is not within limit, then the suggestions are given by the lab expert. Okay, so different kind of machines, different wear particle concentration levels are there, and it has to be maintained as per the oil level, or sorry, oil operation. Then fluorography analysis process. Once the particle counting is done, then the oil is sent to the ferrogram maker. The ferrography is a provides microscopic examination, and for that microscopic examination you should make a ferrogram. What is a ferrogram? uh, that glass slide, you flow the oil, and this ferrogram maker removes the oil, and only particles are left on that glass slide. So this machine main function is remove the oil from the glass slide and keep the particles there only for the further analysis. So how it works, as the oil sample flows in a controlled manner over a glass slide positioned over a magnetic gradient where particles and particulate contaminants are deposited in a specific pattern to form a ferrogram. I will show you one video for this. Okay.
Today we will discuss about ferrography. Ferrography.
Uh, can you hear the from this video? Anybody can reply? Anybody can?
Is a technique for measuring wear particle or analyzing the wear of any material or machine from this technique. Firstly, we will discuss about the parts of the ferrography. We have a magnet, strong magnet, and a inclination glass slide. We have a chamber for lubrication flow. We have an optic fiber which is connected with a lamp, and on the end of the optic fiber we have a photodetector for measuring light signal which will come through this lamp, and this photodetector is connected with the signal which will give us signal. These photodetector give us signal, and we have a capillary tube for inlet of the lubrication oil, and this tube is for outlet of the lubrication oil. Now what will happen? These magnetic particles will be collected in this technique. This side magnet have the weakest field, so larger particle will be collected there, and on this side magnetic field are strong, so smaller particle will be collected there. These particles will be arranged in the decreasing size order. Now we will see the working animation of the ferrography. Lubrication oil will come through the capillary tube and it will go to outside tube. Our magnet will start working and it will collect the magnetic particle from the lubrication oil. These particles will be collected on the glass slide in the decreasing size order. Now this lamp will start glowing and it will give the light to the optic fibers. These optic fibers will strike the lights from these particles, and these particles give senses or signal to the photodetectors. These photodetectors will transfer these signal to the output, and these signal give us output value for the wear particles. From this we can measure the wear of the any machine or any element. This lubrication oil is used for observing the wear in any machine or any element of a machine. So this is the working of ferrography. Thank you.
Coming back to the our PPT. Okay. So once the particles are collected on the glass slide, okay, what will happen? This kind of latest ferrogram maker machine is there. Okay. The ferrogram slide is heated on this heater at around 330 degrees. Okay. Why this is done? Because the particles will stick and will be the part of that glass slide, and during the transportation is from one table to another, the particles will not be lost. Once the heating is completed, keep the slide under the microscope which is connected to the computer to view the different size particles. So you have to keep the slide here and you can observe the particles here from here, and in this way on the ferroscope you can see this. Okay, and you can find out what kind of particles can be seen, what is the size of them, are they alarming, are they moderate, or some retesting is required, or everything is normal. So all kind of decisions can be taken. Okay, and these are the particle size and all these things. Detailed reporting can be done. Okay, now this completes the variability analysis process. Means first particle counts, finding the biggest particles, then ferrogram maker heating the particles, and after that glass slide is kept under the ferroscope and the particles are seen. So which kind of particles are seen on the ferroscope? That is the ferrous, magnetic, paramagnetic, Fe, Fe2, Fe3, stainless steel, and all these things. Non-ferrous particles, that is the copper, alloy, aluminum, barbiturate material, zinc, chrome, and etc. And contaminants also can be seen, that is the fluid, dust, dirt, external process, debris, filter material, friction, polymers, organic matter, and all these things. So each and everything, whatever presenting in the oil, it can be seen under the ferroscope. So how they look like? Okay, you have I have told you that all the particles can be seen. But how to differentiate this is a ferrous, this is a non-ferrous, this is a contaminant, this is a polymer, this is a any other particle is there. So different patterns are there. How they look like, I will show you. So type of particles, that is a normal rubbing wear, cutting wear, bearing wear, severe, sliding gear, non-ferrous, and all these things. So all type of particles can be seen in this manner, and I will show you the each kind of snap. Now you will see all the snaps same. First, if you are looking at all. But what will happen? What happens now? If you regularly practice or regularly you are in this field, then the difference can be identified. I will show you. Normal rubbing wear. If there is no problem in your machine, still such kind of image can be seen under the ferroscope. That is the wear generated during normal operations. I already told you the wear particles. If there is a normal wear, then some particle generation is in process. Okay, small particles. When the abnormal wear begins, then these small particles generation stops and the big particle generation starts. Dramatical change. So such kind of image can be seen for the normal rubbing wear. Then the cutting wear. Cutting wear is a indicative of misalignment or presence of abrasive contaminants, long curly strips of material. See, these long curly C shape, this is C shape. Okay, so don't consider as a normal. Okay, cutting wear, some kind of cutting wears are there, C shape, this kind of. Then the bearing wear. Bearing wear such kind of amoeba shapes. Okay, so this kind of typical patterns of gears you can clearly see here. Okay, flat platelets with perforated surfaces and irregular edges. Severe sliding. Okay, sliding is कुछ तो घिस गया है मतलब means what you can say excessive rubbing is there. The two metal parts are slided over each other. So due to excessive speed, loads, critical contacts, okay, typical rectangular particles parallel to the direction of elongation. Okay, so it's kind of elongated means what will I say? Gujarati people will understand that while making a fafda, they just slide long way that material, okay, the batter. So they slide long way. Such kind of things can be seen under the ferroscope. Gear wear. Gear wear has a typical pattern fatigue wall similar to bearing wear debris. Okay, and you have to identify typical gear. Such kind of slots can be seen. Okay, and easily identified, different from the bearing wear. Non-ferrous metal particles. It is also just like a bearing, but some kind of different shapes you can clearly see. थोड़ा शाइन रहता है इसमें, the shiny particles are there. Corrosion. Long straight hairs due to the acidic attack on the internal surfaces of the equipments. Okay, long straight curly, not curly, I will say long straight hairs type pattern you can clearly identify. Then the black oxide. Black oxides you can clearly see due to the high temperature at critical points. Okay, black oxides, black particles you can clearly see. Okay, and indicative of boundary lubrication condition. So black oxides can be seen easily here. Red oxides, always you can see where, of course they can seen as a red, mainly associated with the moisture. And here due to high temperature means कुछ जल गया है, that burnout type situation. Due to high temperature the black oxides are formed, and due to the moisture contamination in the oil the red oxides can be seen. So excess concentration of moisture reacts with the ferrous components and forms a rust, and that rust is seen. That rust is seen as a red color. Spears you can clearly identify. I've seen one question actually. Online system. Yes, there is online system is available. I will tell you. Spears, you can clearly see the spears in a circle, shiny circles. Okay. Sand dust particles. The sand dust particles, just like transparent हीरे की तरह चमकेगा. Okay, हीरा, the jewel. So deposits over a length of the slide, and you can clearly identify, yes, these are sand dust particles. Friction polymers formed as a lubricant subjected to excessive loads or stress and clearly seen different from other patterns. You can clearly identify here fibers, just like a grass inside the that gearbox. That is the inside contamination from deteriorating the oil filter, outside contamination from airborne asbestos. Okay, long, straight, and curly transparent particles. Okay, so if they are black, then cutting, and if they are shiny, transparent, then the fiber. Water contamination, non-shiny particles. Shiny particles, sand dust particles. Non-shiny particles, water contamination. Okay, so these are each and every snap is different from each other. Okay, so clearly visible water in a sample bottle itself, and if you test it and see under the microscope, then you will see the such kind of particles. Okay, so with this wear debris analysis or ferrography test, we can find out what is happening inside our gearbox, inside our hydraulic coupling, inside our turbine bearings, inside the another the fan bearing system. So wear debris analysis informs us what kind of deterioration is there. If not deterioration is there, the condition of that internal parts we can easily identify. Okay, now apart from this, some high level, yeah, advanced testing is also there. That is the RPVOT test and ruler test. Okay, so RPOT and ruler test is very important, and we are doing since last 5 years for the turbine oil analysis only. These are the costlier test, but we are doing on half yearly basis. So what is the RPOT test? RPOT is a rotating pressure vessel oxidation test that determines the oxidation stability of an oil. Means what? RPOT measures actual resistance to oil oxidation, where the other tests detect the oxidation that is already present in the oil. Ki how much oil, um, how much resistance is remaining in that oil to avoid the oxidation, that RPOT measures, not the oxidation present in the oil. Okay, and the results are reported in minutes and trended against the RPOT of new oil. So simply, the RPOT value should be between 500 to 1000 minutes. If it is on lower side, you must take action. Beyond 200, when the below 200, it is very risky to use that oil. Means it has no power. Um, Internal immunity, you can say, okay, to fight against the oxidation. So below 200, it is very risky to run the machine. Okay, you should not run the machine, I will say. And below 500, if it is falling, then correct level of top up is required, and that has to be calculated. And that top up you have to done, and the value should be above 500. The test is ideal for the large oil volumes with low makeup fluid requirements and also severe duty applications. Means सबके लिए नहीं करना है. The each and every oil, it is not required actually. So the critical machines, that is a turbine. Okay, 40,000 liters or 35,000 liter tank is there, and you have to top up in that how much. So we are using it since last 25 years. So such kind of high level, yeah, I will say advanced testing has to be done. Ruler test, the most important. Ruler is oil analysis measurement help determine if the extended useful life of machine lubricant is possible before the oil drainage, saving the cost, avoiding the risk of oil failure. Okay, means how much I can use this oil further. This measures the level of remaining antioxidant additives levels. See, earlier test was measuring the um, again the power against the oxidation, and this is the antioxidant additives level. Okay, this measures the depletion rate of antioxidant additives present in the oil, allowing the prediction of remaining useful life. Okay, and the result of this test is in the percentage. So ideal oil percentage should be above 30%. Okay, below 30% you should replace the oil, and if it is above 50%, 30%, the oil is in good condition, antioxidants are working, and your machine has no danger. Now we'll see some case studies based on the oil analysis. 1 minute. So what we have learned in last 1 hour, the things that soil condition monitoring is a very important first one. Secondly, the two parts of oil condition monitoring, that is the chemical properties and variables analysis. In chemical properties, the viscosity, tan, TBN, demulsibility, foaming, rust prevention, and all these tests are 4 point, flash point. This indicates if they are within limit, then my oil is in good condition. Then, wear debris or ferrography analysis. This is an important test to confirm whether my machine parts are getting deteriorated or any part is getting damaged or any fault is there. Okay. So in that, the first important step is proper sampling. Sampling has to be perfect, otherwise the analyst do not know from where the oil has came. The machine or ferrogram does not know where the machine is came from. It is assumed that the proper sampling has done. Now it's our responsibility to take the samples from the correct location always. Now, what are the steps in ferrography? Ferrography, the first one is the wear particle concentration. So as I have said, during the normal operation, the small particle generation is progress continuously. But when the abnormal wear begins, the bigger particles are generated, and we are interested in that. From where this big particle has came, and where to find out using the ferrogram. So we again make a ferrogram on the ferrogram machine, ferrogram maker, and we heat it that slide at around 330 degrees. Put it under the ferrogram. We see the different different patterns of the uh, particles. That may be a normal wear, that may be a cutting wear, that may be a moisture, a black oxide due to high temperature, black oxide, moisture, rusting is there, then red oxide, sprayers are there, fibers are there, okay, then the sand dust particles are there, and then water contamination is there. So any kind of contamination, any kind of deterioration, any kind of damage inside the that gearbox, we can easily identify, and the appropriate decision is being taken. And the most important, the critical or the for the critical equipments or the critical machines, the most important advanced techniques are available. That is the RPOT, that is the rotating pressure vessel oxidation test, that determines the ability to fight against the oxidation happening inside the oil. Okay, the value of that should be within 500 to 1000 minutes. Okay, and the second one is ruler test, remaining useful life for the that particular oil. Okay, and antioxidants additives level, ability to fight against the uh, contaminants. So that should be above 30%. Okay, otherwise you have to replace the oil. Now based on that only, we are going to see some case studies related to typically the oil condition monitoring. Okay, and if the time permits, I have to show you the acceleration case study also. Okay, in the morning the topic was slightly big, that's why I cannot show you now. The first case study, TG2, there is the turbine unit 2. Okay, MOT oil, the RPOT value was maintaining on lower side, that is 433. Okay, all other parameters were normal. So with the help of the lab experts analysis to bring the value at above 500, they have suggested us that 13 barrels top up has to be done. Okay, there is a some kind of calculation is there. Okay, they are not shared with us, but it's okay. 13 barrels, 210 liter, one barrel. So 13 barrels of 210 means 2600 liters of oil we freshly added to existing oil of 35,000 liters. Okay, and the results was the RBOT value improved from 433 to 521, which was well within the limit. Means your oil condition is very good. It will not damage to the where it is flowing through to the turbine bearings and all these things. Okay, so oil quality is maintained using the exact top up. So how much top up has to be done is decided by the RPOT value. The second case study, all vibrations were within limit PF and 1B, but the fan bearing temperature was on a higher side, 74 degrees. And we taken all the readings, we are not getting any deviation. So side by side, we sent the oil sample for the wear debris analysis. The wear debris analysis report stated us that black oxide particles and other outside contamination all over the batch. Okay, many Fe fatigue particles also observed in the range from 100 to 700 microns. So they recommended us to clean the oil, centrifuge or filter, whatever you can do at site in running condition. You cannot stop the machine at that time. So we done centrifuging or online, okay, with using a ferrocare machine, and after completing the for 1 week, the bearing temperature, the all contamination was removed by this machine, and automatically as the contamination was removed, the fan bearing temperature also reduced to 10 degrees. No deviation in fan vibration, any other process parameter, acceleration, noise, ultrasonic, or any parameter. But just a 10-degree rise in temperature, we took the help of wear debris analysis, and a simple solution they have suggested us that you should centrifuge or filtration has to be done. The wagon tippler gearbox 1. Gearbox oil found milky. Now, what the report stated, oil found to be milky. Okay. The oil sample reveals oxide and sludge contamination. Other process fluid also check the chance of moisture ingress into the system. And all parameters got deviated here. The simple recommendation was change the oil due to high oxidation, because you cannot see the complete black spot in the ferrogram. So it was simply suggested that the oil has been oxidized highly and you should replace it, otherwise the gearbox may have a problem. So we just simply replace the oil with a fresh oil. So see, in these three case studies, how the different decisions has worked for us. In the first case, we top up. In the second case, we just clean or centrifuging done online. In the third case, simply we replace and the work was done. So every time similar or same recommendation does not works. Okay, what is getting in our report and what action is recommended, that has to be perfectly analyzed. Now, the case study number 4. Conveyor for a gearbox, vibration and acceleration was high. The vibration of motor was on higher side due to the gearbox, and the gearbox bearing acceleration value was on higher side as 3.8. For these type of gearboxes, we have kept the limit of 4.0 and we are getting the 3.8. Side by side, the acceleration value deviated from 1.8 to 3.8. Side by side, you can clearly see the high frequency spectrum. Okay. So the G value, that is the acceleration value, indicated that the high frequencies happen to be bearing frequencies, and thus it was suspected that the gearbox bearing is damaged. To confirm the root cause of abnormality, gearbox oil sample sent for the wear debris analysis. And the wear debris analysis report clearly shown the bearing wear particles. 120 micron, huge, observed in large quantities. Okay. So you can correlate it with the sample pictures that non-aged amoeba shaped particles. Okay. So clear, it was clear from the oil report that the bearing deterioration is in progress. We replace the bearings, not the oil. Okay. And see the results. The acceleration value reduced from 3.8 to 0.8, and motor vibration also reduced to 3.1, because the transference from the damaged bearing was hitting to the, means transferring the vibration to the motor driving bearing. So gearbox bearing vibration and acceleration value reduced to the normal level after replacing the gearbox driving end bearing, which was confirmed using the vibration, acceleration and wear debris analysis report. Now, the now next 3 case studies are slightly lengthy case studies. Okay, it took some time for us, and at appropriate moment we replace or we have taken the appropriate action. So hydraulic coupling bearing damage. So this is a ID fan. Okay, ID fan motor is there, hydraulic coupling is there, step down, and the fan bearings are there. What happened? This is a pre-maintenance history. In the month of January, it started with a deviation in acceleration value. Then we sent the oil sample for wear debris analysis. We found the bearing buried particles. We monitored. Then the ultrasonic reading was taken, deviation notice, then reflected in vibration, then again reflected in acceleration value. And at appropriate time, we stopped the machine, done the maintenance, and saved the huge losses. So each and every point of this we will see in this manner. So what happened? Initially, the acceleration value of hydraulic coupling was deviated from 2.4 to 3.1, and no deviation in vibration level. Okay, noted. The acceleration value limit was 4.0 for this bearing also. So no deviation is observed in hydraulic coupling process parameters, mean temperature, noise, ये कुछ भी कोई changes नहीं था. Okay. We compared the values with other similar 3 fans. Whenever there is doubt or any confusion is there, if you have a similar kind of machine with a similar load, you should always compare. So acceleration value was compared with the other similar fans, and we found that this fan is having a deviation. Meanwhile, the oil sample was sent for the wear debris analysis and clearly indicated the bearing wear particle. You can clearly see here 62 microns, 68 microns. Other hydraulic coupling bearing wear particles were not present. See the comparison in acceleration value also, in the wear debris analysis report also. Here the bearing wear particles were present. Other ID fans, there were no bearing wear particles. Normal rubbing wear was there and everything was okay. Ultrasonic readings were taken. Ultrasonic readings were taken and they also deviated. Meanwhile, the acceleration value deviated from 3.1 to 3.8. Then in the month of August, it deviated, acceleration value deviated to 4.2. Okay. And then it reflected in vibration also. And one day we stopped this fan. So in the view of increasing trend of vibration, acceleration and ultrasonic and wear debris analysis, coordinated condition monitoring decided to replace the hydraulic coupling during the unit shutdown. What was our analysis? Our analysis was the higher frequencies generated in the acceleration spectrum. That was 4.2. Okay. And the non-synchronous value was 2.3. What is the non-synchronous value? Non-synchronous value means any vibration that is greater than 1x frequency but not a whole number of multiple of it. Okay. So if the non-synchronous value is on higher side in acceleration spectrum, the first defect is bearing defect. This is a Google table, Google information. Okay. So whenever the non-synchronous value is on a higher side, the first defect is bearing defect. So what was happening in the machine? The stress waves of high frequencies generated and such kind of defect was present there and impacts were there. So decision taken to replace the hydraulic coupling. Once the decision was taken, the machine was under maintenance. Alignment between hydraulic coupling and fan found disturbed due to the increased bearing clearances. Minus 90, minus 80, there was a difference. No secondary damages to fan shaft, motor shaft, hydraulic coupling shaft, bearings, each and every part was okay. Fan internal inspection was done, no abnormality notice. Means what? No secondary damages. So hydraulic coupling decoupled from the rest of the drive, oil was drained. New serviced hydraulic coupling was New service hydraulic coupling was placed and aligned with the motor and fan. Fresh oil filling done with a new hydraulic coupling. Motor to hydraulic coupling to fan coupling was done. See the results. The acceleration value which was on higher side 4.2 reduced to 1.2. Okay. The vibration also reduced to 2.7 to 1.6. No impact on motor and fan side. Ultrasonic reduced readings also reduced from 6 to 3 LEDs. And see the results. The bearing, after 15 days of operation, we took the oil sample and sent it for the analysis. And whatever the bearing particles were seen earlier, now there were no bearing particles. What is the benefit? This fan has no standby, and if this fails, then we will have a generation loss on higher side, and plant we cannot control with one ID fan. Okay, so huge losses were saved. This critical fan we have saved. No damage to motor or fan side. We simply monitored the hydraulic coupling parameters, and at the correct time, we took the shutdown and replaced the part. Now, this is a unique case study for the wear particle concentration. That's why I have included in this forum also. Coal mill 2CD, main reducer gearbox output shaft replacement. Okay. From the picture, you can see this is the input, this is the intermediate, and this is the output shaft. What happened? Each and every point we will discuss. In the month of in 2018, in the month of October, we found deviation in the wear particle concentration, bearing wear particles, and all these things. Okay, in the coal mill reducer gearbox, and such kind of bearing particles you can easily see. Oil parameter deviation discussed and decided to inspect the main reducer gearbox bearings during the opportunity. We found the increased clearances and intermediate gearbox gear replaced with a spare one in presence of OEM and fresh oil top up was done. In the month of after 2 months only, December, again the bearing particle increased. Okay, again the bearing particle size increased. Same issue was discussed and 15 days resample करने के लिए बोला गया and we took were in the process of monitoring of vibration and acceleration parameters because just 2 months were passed. But after again with a close monitoring, again resampling was done and the wear particle concentration again increased and beyond limit this time. Okay, showing the bearing particles of 68 microns. No deviation observed in vibration, acceleration, noise, or any other process parameters. Looking at last three reports, repetitive oil parameter deviation of reducer gearbox initiated a visual inspection and suspected that something is there. We are not finding, we are not getting, but something is there. That's why the oil parameter deviation is noticed in 2 to 3 months immediately after even after replacing the oil, replacing the bearings, and all these things. So this decision was taken in a meeting that during the opportunity you should inspect again thoroughly the reducer gearbox. We got an opportunity in the month of May, April. Okay, after 1 month we got an opportunity and thorough inspection, checking clearances of bearings, backlash, everything was done, and we found major deviation. Output gear shaft found cracked at driving end side originated from the keyway. What is our in mind generally? Yes, I have replaced new oil. I have put my new bearings. So naya hai, acha hai, everything is good. Why this should happen? The lab person may be wrong. This may be wrong. Galat report ho sakta hai. That's such kind of things may happen. Here also happened, but we kept eye on the reports also, on the parameters also. Ki one time the report may be wrong, second time no, third time it should not be, and all the 3 times the reports were stating that something is there in your machine. So during the thorough inspection we found the crack. We done the LPT test for the surface crack and found easily the crack length and depth. Then it was easy for us. Main reducer gearbox decoupled from the rest of the drive. Top cover removed, output shaft taken out, coupling removed, new output gear shaft installed. Okay, top cover placed. Somebody is desperately calling me. 1 minute. Hello. हां हां थोडा वेळ सर माझं लेक्चर चालू आहे मी 4:30 ला पाठवतो. Sorry. So actually the audit is going on. Some calls are coming. That's why. But अभी call नहीं आएगा. So once the fault is found, we replaced the output gear shaft and aligned the gearbox. Again, we after 3 to 4 months, we checked the wear debris analysis, and we found the vertical concentration below the alarm level, and the bearing wear particles were reduced from 68 to 36 microns. Okay, in this way. So, what was the conclusion for this case study? The case study has clearly demonstrated that oil condition monitoring is a vital tool, detecting the abnormality well in advance, even there is no reflection in the vibration, acceleration, noise, or any other process parameter. Do not overlook the repetitive high wear particle concentration of reducer gearbox analysis, which initiated us, which forcefully told us, जाओ कुछ तो करो वहीं पे कुछ तो गड़बड़ है. Okay, so repetitive high wear particle concentration of repetitive reducer gearbox analysis initiated a visual inspection and suspected that in spite of changing intermediate gear bearings and oil, why the wear particle concentration is on higher side. That mystery we have solved by checking the gearbox thoroughly. That time was also checked, but at that time the crack may be of small size, and then it propagated and the particles were coming from that, and that initiated us for the visual inspection. Now the last case study I'm going to discuss with you, that is the ferrography, specialized oil analysis for protection and diagnose the gear or bearing particles, gear and bearing particles. Again, this is another coal mill. Okay, the gearbox maybe you see same, but this is another case, another history. This man is there for me always. We will see each and every point. This happened just before the lockdown. Okay, the first lockdown. As per the quarterly schedule, the oil sample was collected for the variability analysis. The person came and he took the oil sample. You can clearly see the date. There was a thread. Oh, lockdown lag sakta hai, ye hai, wo hai, and the oil sample was collected. He gone. And the oil sample report stated that the wear particle concentration is on higher side 1219 against the limit of 1000, and bearing wear particles, copper alloy particles were on high size of 72 microns. Okay, so oil parameter deviation discussed in a meeting and decided to inspect the gearbox during the opportunity. So meanwhile, what we have done, our condition monitoring team has taken vibration reading, acceleration, distress level, noise monitoring, ultrasonic, all the readings were taken, but no deviation was found. Okay, all parameters were within limit. So based on that report, we initiated for the wear particle, internal gearbox inspection. We got opportunity after 1 month. What was the oil condition monitoring report was stated 72 micron copper alloy particles followed by a high wear particle concentration. You can clearly see the copper alloy particles of bearing in the ferrography or ferrogram. Okay, some sand dust particles, normal wear particles were also there, but the crucial parameter was this one. Observations during the maintenance. Condition of motor and main reducer gearbox side coupling was okay. No secondary damages. Main motor D bearing also inspected. All clearances found within limit. Main reducer gearbox, internal inspection done, input bearing clearances found within limit, no abnormality noticed. Input okay. Output bearing clearances found on higher side as 0.5 was the limit. Sorry, against the limit of 0.3, we found the 0.5 mm clearances. Means the clearances were on higher side. That's why the 72 micron particles were coming. Micro pitting on the roller, scoring marks on the inner race observed on intermediate bearings. During thorough inspection, main reducer gearbox, minor looseness noticed in intermediate gear spacer. So with these observations, we decided to replace the intermediate and output gears. So main reducer gearbox decoupled, top cover removed, reducer gearbox oil drained and filtration done as per the oil sample report recommendations. Okay, they said that the oil is in good condition. You check your machine parts and you can reuse the oil after the filtration. So both oil samples used and filtered sent for the chemical analysis, because at that time the lockdown was on peak. We were unable to send the oil samples to the lab at Hyderabad. So intermediate shaft taken out, bearings removed, gear inspection done by observing micropitting looseness on the gear spacer. Decided to replace intermediate gear with a spare serviced one. Okay, with the new bearings. Output gear shaft taken, bearings removed, and new bearings installed. Everything installed and filtered oil put into the gearbox. We are not replaced that oil. Okay, because need nahi tha. There was no need. Everything was taken done, and after the maintenance work execution, cold mill trial taken. Vibration, acceleration, distress level, noise monitoring, ultrasonic, everything was within limit. And the oil sample report. Okay, after filtration, the impurities reduced from 0.24 to 1.0, 0.10. Okay, the impurities level also reduced to the normal level. Okay, no deviation in any condition monitoring parameter. So this case study says that high wear particle concentration and presence of copper alloy particles of main reducer gearbox initiated inspection and suspected that deterioration of bearing is in progress. So whatever comes with that report, you should clearly identify, never ignore the deviations, or if there is a need for filtration, if there is a need for replacement of oil, if there is a need for top up, if there is a need for where means bearing replacement or gear replacement, you should initiate a maintenance execution plan. And even after the execution of plan, you should not be relaxed. अभी तो मैंने oil change कर दिया, I am happy and no problem will be there. So such kind of things should not be there. So case study number 6, we learned that in spite of replacing the oil and bearings and all this, we missed that crack. But we are very fortunate that no accident took place, and we found with regular monitoring, and in next case we detected, means next level of we detected well in advance, and fortunately we saved the gearbox. So what is the conclusion behind this? Ferrography provides an early warning of abnormal wearing in lubricated components, ensures that proper oil or grease is being used, monitors the lubricant use, contributes the machine system cleanliness. This addresses the wear, contamination, degradation, and gives recommendations, and it discusses the principles and guidelines for the sampling. कहीं से भी सैंपल नहीं लेना है. Okay, warning limits and corrective actions. So with this, I will thank for you listening patiently after the lunch. And still anybody wants, I will answer all the questions again, I will say. And still anybody wants any specific case study, because I have a lot of case studies. Even I have written a book also on a case studies that is a will be shortly published all over world. Okay, So any specific specific case study if you needed from my side, you can simply say that. And over to you, sir. Any questions? Just let me know.
Yes, sir. There is a question. One of the participants, Samira Mufazzal, is asking that in particle analysis, if two or more components are made up of the same material, for example, the bearing and the gearbox, then how would one know from where it has been exactly generated?
Uh, Suppose a gearbox and bearings are made up of same particles, and you are getting a particles one of getting. So what will happen? Again, you have to inspect. See, suppose the bearing particles are the particles getting from bearing you don't know, but you will came to know that the particles are coming from particles are from of this material. So you will clearly know that either it is a bearing or gearbox, but the particle is coming means out of 10 machines this machine has to be inspected. So you open the gearbox and check the bearing clearances. If the bearing clearances are within limit, there is a problem of gears because the particles are coming. And if the gear is okay and your bearing has a high clearances, then you have to replace the bearings. So bearing clearances will play a vital role here during the inspection. In last case study also, we got the clearances of 0.5 mm instead of zero point 0.3. 0.3 was the limit, but we got a zero point 0.5. So in this way, if this is a very rare case, but still I will say, if the bearing and gear are of same material, you should inspect or you should go for a bearing clearances.
Okay, sir. Another question from Mr. Muhammad Atif Jamil. He's saying that in academics, most of us are involved in some sort of research in the area of condition monitoring. But in your interesting sessions, I didn't see much of the mathematics involved. So I'm interested to know what level of condition monitoring expertise is needed to be a maintenance professional in the industries.
Yeah, you have not seen any mathematical calculations because we are not teaching any theoretical theorems or anything else in anywhere. We are directly we know the background of calculations, okay, and we are directly applying that in a plant in real life. Just I have said in the morning also. Ki, suppose I detected a misalignment. Nobody cares कि it is a parallel or angular. Misalignment is misalignment for the industry. Again, if I say with the help of acceleration value only, uh, there is a bearing damage because acceleration value is on higher side. This is a bearing damage. You have to replace the bearings. Nobody asks or nobody is interested in the industry that no, no, inner race damage hai ya outer race. Please tell me. Then only I will start the work. No, it's no. It's not required at that stage. Otherwise, the calculations are there. This is the number of roller elements, this is the alpha angle, and this frequency is 22270, and this is present in my spectrum. That calculations is not required to be shown to the maintenance people because they are not interested in real life. Okay now. So for the students, I will again say, for the students or research people, these calculations are required. We don't care number of rotor bars are damaged, one or two or three. One damage is also damage for us, three damage is also damage for us. Tentative calculation formula is there, but in real life it is not required. That's why I have not shown any calculations there. Even we use high quality means high end advanced softwares that directly gives us the defect frequencies, the motor current index and all these things. So we are interested in the final results only. The background calculation the expert will know, means in our plant we are three experts are there. Okay, one my junior colleague and one my senior colleague is there. So if we three of us know very well, the rest of the plant is not interested in that. They interested what has to be done, you tell us the exactly. So your second question is ki what kind of expertise is there. I will say you should be firm on your decisions. Once you detected a misalignment using a spectrum analysis, using a phase analysis and all these things, you should be firm. नहीं यही है. Of course, you should be very very firm after the cross checking. दो बार तीन बार रीडिंग लो, चार बार एनालिसिस करो, वॉट एवर हिस्ट्री देख लो, हिस्ट्री पैटर्न देख लो, दूसरे का स्पेक्ट्रम देख लो, वॉट एवर everything you see, but at the time of meeting you should be a very firm, just like a doctor. आपको मलेरिया ही हुआ है, no other disease. Similarly, you should tell the maintenance team go for a maintenance alignment only, not the bearing or not the gear. Replace the oil means replace the oil, no any other part replacement. So that kind of expertise has to be there. Background calculations and all these things are there that are important, but in real life keep it with you only. Whenever proving is required, then only show कि भाई ये calculation इस तरह होता है, इसलिए मैंने बोला कि ये है. That's it. Otherwise you should be very firm and that expertise has to be achieved. I hope it is clear, sir.
Yes, sir. Thank you for the answer. I hope, Mr. Atif Jamil, your question is answered and your query is taken very well by our esteemed speaker. And sir, there is one question, not exactly a question, rather a
Yeah, please.
request from Rahul Kumar Sinha,
Mhm.
that he want to see some of the case studies on multi-stage centrifugal compressor, turbine, if obviously if possible. Maybe in the future,
We
in some talks, you can incorporate these things.
Yeah, we don't have multi-stage compressor. It is in gas turbine generally. Um, Gas turbine, there is a multi-stage compressor. And turbine case studies, we have balancing case studies only. Okay. So during the shutdown, we replace various parts, bearings, means HP modules and all these things. HP मॉड्यूल है, आईपी मॉड्यूल है, एलपी टर्बाइन का ब्लेड में हम लोग सैंड ब्लास्टिंग एंड क्लीनिंग एंड ऑल दिस थिंग्स करते हैं. So due to this, any part if we replace, then balancing is required. So balancing we do it, and accordingly that case study is there. Okay. सो कॉम्प्रेसर का ऐसा केस स्टडी नहीं है मेरे पास, लेकिन गैस टरबाइन का एक अलाइनमेंट का एक केस स्टडी है एक्चुअली. So if you are interested, then I can show you. What kind of case study, Mr. Rahul, you are expecting from multi-stage compressor?
Mr. Rahul Kumar Sinha, you can type your response in the chat box. I'll read it for you. Meanwhile, sir, Mr. Mohammad Atif Jamil is saying that thank you for your elaborated response.
Thank you, sir. Thank you. Thank you.
And if there is any other question from any other participant, you can just write your question in the chat box. Yes, sir. Mr. Rahul Kumar is saying that some issues related to bearings and gears in compressor.
Yes, मैं 2000 मेरा शादी हुआ 12/13, 2013 की बात है. ओके. Mr. Rahul, this is the answer for your query. Ki what happened in that gas compressor? In our Cochin plant, okay, in a Cochin plant, should I share the case study? It will be okay, or just I will talk.
Yes, sir. If you want, you can share it. We still have 15 minutes left, 10 to 15 minutes.
Okay. Sorry. Three to six. Okay. We will discuss each and every point. 2012. Sorry. This plant was a reserve plant. Can you see the case study? It is okay, na?
Yes, sir. Yes, it's visible.
Okay. So what happened in 2012? Plant was running uh, after being back down condition from last 18 months. It was not in service. Okay. And suddenly it tripped on load exertion and dropped to 0 megawatt. So this was a gear train or a machine. The gas turbine was rotating at 9000 rpm. 9000 rpm में से एक shaft बाहर आता था. 3600 rpm high speed gear. Then here are two bearings. Then speed reduction. It is connected to generator and etc. Now what happened? There is a safe set coupling here at bearing number 3. Okay, bearing number 3 here one set coupling was there. Means if sudden load throw off is there, then to avoid the damage to the generator and the gearbox, the set coupling was having a function that it was disengaging the 9000 shaft, that is 9000 shaft to 3600 shaft. This was the pin set oil charge through charging point. This pin was there, ये निकल जाता था. So what happened on that day? The pin was released suddenly due to the sudden load throw off, and then what happened? Again the machine was started, but machine start करने के बाद the high vibration it tripped. Then they called me. Internal inspection was done. Sorry, before calling me, the internal inspection of gear and all the things were done. Everything was okay, and subset was released and taken into the service. Again, the machine was stripped without load. Okay, machine was withdrawn Then what happened? I was being called from my plant to the Cochin plant, okay, and I took some data. I took the data, found the vibration on a higher side, okay. I took the phase readings also, okay. Here the phase data you can clearly see, and across the coupling I found the 180-degree phase difference. Now 180-degree phase difference was there. That's why also this shaft movement was also noticed under the strobe light. Now after this all the things, misalignment, I detected a misalignment in that particular machine and informed the GE people that alignment has to be done. But they said that the alignment will be done with the help of balancing. Balancing weight was installed, but the vibrations level were on higher side. And finally, मैं मेरे decision पे फॉर्म रहा कि you cannot do the misalignment, you cannot correct the misalignment with the help of balancing. So they finally listened to me. Then the alignment correction started. They found misalignment. Okay, misalignment was on higher side, and shims were installed. 0.25 mm का correction आया, वो सब कुछ किया. Okay. Meanwhile, all the bearing, thrust pad, everything was done. Final alignment was done, and the machine started, and all readings were within limit. Now, why I am telling the story? After that, everything was okay. My analysis was perfect, and all the things were perfect, appreciated by the senior management and all these things. Now, the real story begins from here. After the alignment, the one more scenario came in front of us. After 6 months, okay. One more scenario was that in the morning, the vibration levels were maintaining on lower side. When the ambient temperature was reaching on higher side, that is 12 o'clock, 1 o'clock, 2 o'clock at around, the vibration level was also increasing. After 4 o'clock, the vibration levels were coming down. In the night, it was stable. We checked all the things, referred to the OEM and all the things, and we checked all the parameters, and we got the solution from one of the old plant in the somewhere in the America. They were also facing, they have also faced some kind of problem in the history, and they replaced the gearbox bearings. Why this was happening? Because the first time after 18 months we started the plant, the machine tripped with a heavy load that impacted badly. SafeSet has saved the gearbox, but the bearings got heavily impacted, and due to that, this alignment disturb, alignment to disturb हो ही गया. But after correcting the alignment, that position of the bearings also disturbed, and they were behaving such kind of misbehavior during the daytime, nighttime, and all these things. So we replaced the bearings, and after that it was all okay. So I just wanted, I came across this kind of case study only till my career. Okay. So I hope you got the answer. Okay.
Okay, thank you, sir, for your for showing another case study. And if there is any other question by any other participants, please write it down in the chat box.
Somebody has asked that online oil condition monitoring. Am I correct, sir?
Sir, I cannot see his question. Maybe he has messaged you privately.
Mm, I cannot see here private messages. Yes. Yes, 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 yes. A lot of questions. Audible, audible. Is there any online vibration, online condition monitoring system? Online Vidyadhar Krishna. Okay. Do you want to say online oil condition monitoring? Say yes. He has written again. Okay. Yes, there is an online oil condition monitoring system is available, and Predict Technologies has a patented sensor for that. Okay, and I'll just show you again. Sorry, just मैं सेंसर दिखा देता हूँ आपको. 2021 online OCM. Wait a minute. Yeah, this is a online oil condition monitoring sensor. Okay, whatever the threaded portion is there, uh, from means where the thread portion ends, the remaining part should be submerged in oil, flowing oil. The sensor senses all the things. Okay, and here the dimensions. You will get all the display here, and some more sensor system is there. Sorry, yeah, this much. 1 minute. I am not getting the correct sheet. Yes. So whenever the sensor is submerged in the oil, okay, you will get these parameters. How it works and all these things. Interested people can take me from this. So you will get, see, the sensor will detect oxidation, tan changes, TBN changes, additive depletion, wear debris, process related, environment related, partially burnt fuel, water contamination process, measure all the things it will collect. Okay. So online oil condition monitoring system is available. Okay. One or two plants in the India it is installed. We are also in the mood of that and we are studying on that. Okay. So this is the answer for your question. Okay. Any other question? What is the setting for Fmax in acceleration? Um, Fmax setting acceleration. There is no Fmax setting for the acceleration. You just take acceleration readings 0 to 5000 kilowatts or 0 to 3 lakh CPM. Everything will be covered. No problem. Uh, Attendance link. I couldn't see the feedback. I would like to some case study on the multi-stage compressor. Yes, reciprocating possible. Some issues related to bearing answer gears in compressors. Anything to? Okay, I hope all the questions have been answered. Or do you?
Yes, sir. All the questions have been answered, and on behalf of the organizing team of this FDP
Anybody?
online.
Yeah, I will also typing my email ID and anyone required. Okay.
Thank you, sir, for sharing your email ID. Shmi, actually, लक्ष्मी साहब का ये क्वेश्चन है जो
This is my WhatsApp number. You can also WhatsApp any issue, any technical guidance is required. Okay. Always available.
Okay, sir, on behalf of the organizing team of this FDP on machinery condition monitoring, I thank
Yeah,
you for
one question came. So please
no,
wait.
no,
I
no, sir.
cannot go.
No
Sugar
worries.
plant, high speed rotating fiberizer. Yes. Beginning of career, I was looking after 4 sugar mills in Maharashtra, and fiberizer was my favorite machine. So fiberizer having a means not a high, it is not a high speed. The motor is high speed, but the rotor is a slow speed machine. And generally, the balancing problems and the bearing problems where I have noticed. Okay, and motor as such, no issues we have detected. Thank you. Yes, please go on, sir.
Sure, sir. So, sir, thank you for delivering such an enlightening lecture where you have given a deep insight about the actual physical problem of the industries, and especially wherein you have shared a lot of case studies which otherwise we couldn't have understood without your help, and we couldn't have found that case studies also. So thanks once again for agreeing and taking out the time from your busy schedule to deliver this lecture, and especially the case study parts.
Thank you, sir.
And we also hope to see you very soon at Delegate Muslim University.
Yeah.
And
Oh.
maybe if you remember, you were once here around
Yes,
2016
I
or
know, sir.
17.
I know, sir.
Yes, sir.
Yes,
So
yes.
we hope again to see you sometime soon in the near future, sir.
Sure, sir. I'm waiting for that. Thank you.
Thank you, sir.
Thank you. Thank you. Okay, bye everyone. Thank you.
Dear participants, the feedback attendance form is they already there in the feedback, sorry, in the chat box. So kindly use that link to fill your feedback and the attendance. And again, the tomorrow's session will start at 9 a.m. And also, I would like to remind you that tomorrow you are also having your exam. That will be a multiple choice question type of examination. And it will start from 2 p.m. and it will be a 1 hour examination. So it will be from 2 to 3 p.m.